Now this is divergence of a vector. Let us consider the point charge. This is the positive point charge, right? This is positive point charge. So we know that charges around which the field will be there. Okay, the field of lines will be there. Those fields of lines will be outward from the positive charge, like this. It will be outward like this. It will be outward from the positive charge. It will be outward from the positive charge. What is happening? These vectors, vector field are the vectors. Okay, so these vectors are going out. Those are diverging. Okay, those are diverging from the center point. From the center point, those are moving away. This is called as divergence of a vector. So these are what? These are the field fields of field of lines. Okay, field lines. From positive charge, it is moving away. The direction is always taken from the positive to negative. Or if you say the torch, okay. So when the light is there, when light source is there, say this is a light source. Okay. So this is the light source we have. What happens? The light will diverge from the single point. When I on the bulb, when I on the light, light will diverge from a single point. That is the divergence. Okay, so this is the divergence of the vector. And for example, this is the divergence. Okay, then for example, if I have the positive charges like this, which are accumulated on the plate. This is a plate, okay, and which are accumulated on the plate, right? Then these lines of forces will be what? Outside, from the positive to outside. Those are going out from the positive, because this is a linear. Okay, a field is going out. Here there is a divergence is there. At this case, in this diagram, we can clearly see the divergence. Is there any divergence here? If I take laser light, okay, when laser light is like this, okay, what happens? The lines are going parallel to each other. Okay, parallel to each other. Those lines, light waves or a light rays are parallel to each other. Is there any divergence here? There is no divergence. There is a divergence. Divergence is taking place. Here there is no divergence. No divergence means what? No divergence means what? The divergence is equal to 0. There is no divergence means divergence is equal to 0. There is a divergence from the single point. That means this is the positive divergence. This is the positive divergence. Okay. So mathematically, how can we write this divergence? Divergence can be written as del dot A. This is the divergence of a vector mathematically. What is this? This is the del operator. Okay, this is the partial differentiation of 3 dimensions. This is del operator dot A. This is called as the divergence of a vector that is departing from a single point. That is departing from a single point. That is called as the divergence. Okay, and the divergence is written as, divergence can be written as, I'll write the definition first and we'll try to construct the mathematical equation for that. Okay, the divergence of a vector field is, it is divergence of vector field A. Okay, this is the divergence of a vector field A. This is a field. This field itself, you can take it as A. Okay, this field around this point charge, you can take it as field A. Okay, this is also vector field A. Its divergence can be given as outward flux per unit volume. It is outward flux per unit volume. Okay, per unit volume as the volume shrinks. Volume shrinks to zero. Okay, let us analyze this definition. What it says, the simple definition we understood, divergence means departing from a single point. The rays are going out like a light rays, like a torch. Okay, those are going out from a center point. That is a divergence. Or when college leaves, okay, in the evening, we depart from a college single point to the Belgium, to anywhere, okay, away from the Belgium. So we depart. That is called as a divergence. Divergence of students. We are diverging. In the same way, these vectors are diverging, or vector field is diverging from a single point. That definition says it's the outward flux. What is happening? The flux, these are the flux. Okay, flux means the lines per unit area. The flux is moving out. It is an outward flux per unit volume. Okay, per unit volume. How much it is going out? If I take some volume here, if I draw some volume here, if I draw to this diagram, if I draw some volume, how much it is going out from a single point? Okay, it is called as divergence. Another condition is what? As volume shrinks to the zero, or this is simple, it is simple limit. We are limiting to some volume. Okay, so we can take that volume from 0 to V. That I'll write equation as, equation can be written as, or I'll put that point, inside the box. Let me put that point inside the box. So I'll consider this volume. This is the volume. This is the volume. Okay, inside that I'll put this point P, or you can take Q. This is a point Q. What it is happening? It is radiating the flux. It is radiating the flux. Okay, it is emitting the flux like this. So these flux are going and hitting to the box. Can you imagine that? So these are going and hitting to the surfaces of the box. That means the outward flux which is hitting to the volume. Okay, and for this axis is what? This axis I'll take as delta x, a small unit it is, it's a small segment. It is the delta V is a small segment. So along this is the delta x, along this is the delta y. Okay, if you take along this, that will be delta z. Okay, if you take along that, that will be delta z. X, y, and z, three axes I have taken. When you multiply that, what will get? You will get the volume. It's very simple. So this is the point which is hitting to the surface. Then what I want? I want the divergence of the vector A. I want to find out the divergence of vector A. The divergence of vector A is given as, it is outward flux. It is what? It is outwards flux. Okay, outward flux of what? Flux of vector A. Vector A is going out. Outward flux divided per unit volume. What they say? This is per unit volume. What is unit volume? This is the unit volume, per unit volume. Okay. Next sentence, as volume shrinks to zero. What they are telling is they are limiting it. They are limiting it. How much they are limiting? That is shrinking to zero. Okay, that means some kind of a limit we are giving to that. So this is a limit of delta V tends to zero. So this is the definition of divergence of a vector field A. Okay, what it says, very simple, outward flux per unit volume, only that much. But another condition we have, why it is that we are going to discuss. Outward flux per unit volume as volume shrinks to zero. The same sentence I have converted into mathematical equation. The divergence of A is given as limit of outward flux of A divided by delta V. That means per unit volume. As this limit, what it limiting? It is shrinking to zero. Its limit meaning itself is like that. Okay, limit meaning is if it is shrinking, then we have delta V is tending to zero. So this is the definition of that, and we can write this the divergence as like this. It is del dot A. Okay, it is del dot A of a vector field A. And this del dot A, this is one definition. Okay. So what is del? What is del? Del is, we know the del is like this. It is dou by dou x plus. It is dou by dou y plus. It is dou by dou z. Isn't it? This is the definition of the del. Okay, with the unit vectors. Unit vectors are what? Unit vectors are I, it is j and k. These are the unit vectors. Okay, of what, on what we are applying? We are applying a dot product is there. We are applying on the vector A. Okay, vector A. Fine. And then that vector A can be written as in the components. In three components, we can write that vector A. And that can be I dou by dou x of Ax. Okay, this is x component of this vector. J dou by dou y of Ay. This is y component of a vector plus k dou by dou z of Az. This is z component of a vector. Okay, this is the mathematical form, and when we are going to solve the equation, when we are going to solve the problem, we should consider this significance. Okay, of a divergence. Of the divergence. So when the positive, when we take, the fields will go away from this. Okay, the fields are going away from this. At that time, the del dot A is positive. This is positive. Okay, the divergence is positive here. And when I take negative, the fields of line tends to come inside. These are like this. So these are, here we have negative divergence. Divergence is what? Negative. When the fields of lines are straight, when field is moving like this, okay, at this point P, what is the divergence? What is the divergence here? Divergence of vector A is equal to 0. Okay, so here it is positive, here it is negative, and when the fields of lines are parallel, the divergence is equal to 0. Divergence is equal to 0. What it says actually? How much field is diverging? It says, it tells us how much a field is diverging. How much field is diverging? It says all about how much field is diverging. Okay,